what I'll do is I'll have you take the final exam, but the last page of the final will be some Excel work. So the stuff that we're going to do in class, bringing that heavy car over and having you practice on Excel, do practice it at home, and I'll try to do something where we make a video step-by-step showing how to do things so you can sit at home and actually do this. But you will be looking at data, evaluating that data, and examining whether it's a trend up or a trend down, and looking at the slope and the y-intercept. The y-intercept does become important in certain cases, so I want to show you those cases. But we'll practice that for the rest of the semester, along with every day taking some of the older problems that we had trouble with and then practicing them again in the class.
When is our next test?
Next week.
From today?
From today. Next Monday. The 20th. So exam 3 is next week. It's going to consist of problems from the quizzes, problems from that we're covering today, and problems from exam 1 and 2. So the only new stuff that you're going to get, it's not really new stuff. I'm going over the stuff that we went over the last couple weeks slowly by video, because I now see how important it is. I think we just got used to it. Everybody just got used to having the video to fall back on. But today we're going to cover a couple more problems. They're more complicated problems than what you've done in the past, but everything else is stuff that you've covered before. Realize exam 2 was comprehensive, so you had exam 1 material in there. So I would review the exams, review quizzes, review in-class assignments. That's exactly where I go to build my tests. I just go back on old stuff, mostly because I can't remember anything. Next, on Wednesday, we have Dr. Yuri Jadote, who's coming here. He's a former Montclair State student in the Health Careers Program who had a 4.0 here in the college, and then he went on to medical school at UMDNJ, has had a wonderful career. He's not that old. He was probably here in 2005, so it's not that long ago that he was a student. But you can submit questions that you want to ask him about how to get into med school, what he thinks was most important, what kind of experiences you can get here at Montclair State to best equip you for getting into any health-related career. He's the person to ask. So if you submit your questions to me earlier, I can send them to him, and then when he projects into our class on Wednesday, he'll be ready to answer the things that are of interest to you. Who gets into the classroom first? Who come? I know you guys are all in here before I get here. Who's in here early? Can you police, because it's being advertised across CSAM, can you police and make sure that the front rows are kept for us? And then, so if you see people coming in that don't, bounce them, man, put them in the back, okay? Make sure that our students get the front.
Don't worry, I can do it. It's me.
I believe it. All right, so that's what we'll do. Crowd in the front, because I want you guys to be able to have first questions and first chance to ask anything and hear anything he has to say. You know, it's for our class and then everybody else, not the other way around. So today what I'm going to do is go over another asymptote problem, and I think that the steps that you went through on your quiz just now, that was probably hard to see step by step when I did it on the board, although I did see some of you have it. We'll do it together now as a video. So here's a problem you're supposed to determine. Well, the question is really to graph it. I told you that before, that this is a old school kind of question because you have the graphing calculator and you can see the whole thing. So it's kind of an outdated question, but they want you to be able to graph this problem without any calculator. That's as if you didn't own one. But the first step is, if you had the answers, wouldn't you find them? So the first step is to graph that on your calculator. The graphing calculator that's online is very much like the 83 and the 84, those ones that have the lines in them.
I figured out why my thing was going along. Because one of the settings, well, she kind of figured it out, but my calculator go out. But one of the settings on Windows, like the XRES, it was set to like 3 instead of 1. So if you set it to 1, then it goes away.
Well, that's because of the grid lines. You're telling it how far apart to take grid lines. But on the newer calculators, you don't have to type anything. It knows that those lines aren't there. So what lines am I talking about? These lines right here. See where I put vertical asymptote? When you have those lines coming down, it tells you that that's a vertical asymptote. So you get the answers right away. Right over here, those lines shouldn't be there. They're an artifact of the calculator if you have an older calculator. I believe if you have 84 plus and above, you're fine. It's the 84, 83, and one 84 plus in here, it had this problem that it gave you those lines. Do not draw those lines, ever, because it's a signal to someone, it's a flag to someone that you don't really know what's going on. Because it is an artifact of your calculator, so if you're drawing it and repeating it, it means that you don't know what's going on, which is not true. So don't draw it. So really, I tried to erase it by scribbling over it with a white pencil, and you see, that's the picture you should be drawing, not the other one with the line in between. So just eliminate the line, consider it all blotted out, and draw this picture instead. Another weird thing is on the older calculator, you notice that it doesn't actually go all the way down here. It just connects the two things and it kind of stops and makes a piece. You just have to know that that's an asymptote. And really, I extended it with a pen. You can see that I extended it. It's supposed to go down. So an asymptote's an actual hole in the graph. You have that it goes to heaven beforehand and it goes to hell after, goes to hell before and goes to heaven after. So you have two asymptotes here. It's an entire hole in the graph where we call it a shock. It's in physics, it's called a shock. So if you want to know where that asymptote is, especially because you have two here, you want to recenter your graph so that you're located right around the asymptote. And you can see in this case, it looks like it's really close to 5, around 5. So it's not perfect, but it's pretty close to 5. So I'm going to guess, because it's a textbook problem, that it is 5. And my windows were set to 4 to 6, so I can see where it is.
I have a question. So what happens to the one in the bottom?
I'm going to get there. There's another one around x equals minus 5. There's 2 of them. So I just went to the big graph and then recentered it. So there's 2 different ones to look at. Sure. That one?
Yeah.
Good? That's the other one. Okay, good? So what is it they really want you to do in this problem? They want you to find the roots, the asymptotes, and the shape of the graph analytically or algebraically, as if you don't have the calculator. But any fool who has the answers will look at the answers. You ever just look at that psychological test that they have with little kids where they say, there's a toy behind you, but don't look at it? Every kid turns around and back and looks at it as soon as the researcher walks out the door. You gotta look. We're human, we'll look. So we know the answers. But how do you find it analytically? And this is, in Calc 1 and 2, students have such trouble with this because if they don't know how to use their calculator, they're stuck using it this way. And it's such a process. Write out a step so that you can see the process. First is you find potential values for vertical asymptotes by setting the denominator equal to 0. And I just copied and pasted the problem so you can remember what the problem was, because you start to forget. But just set the denominator equal to 0 and solve. And what I did here is I factored out the x and x squared, so I get this guy here. If I multiply forward, you get x squared times x squared is x to the 4th. X squared times minus 25 gives you minus 25x squared. So this is factored out the other direction. And now I can factor one more time. And I get x squared times x minus 5 times x plus 5 is equal to 0. And that gives me the potential places for an asymptote. One is x equals 0. One is x equals 5. And one equals x equals minus 5. Now what do we know from the drawing of the graph initially? Where were the vertical asymptotes and how many were there?
3.
Were there 3? Do you remember, Danielle? There were only 2, right? So one of this is a fake. Which one's a fake? 0 is a fake because we already know the answer. It's minus 5 and 5. But this is the kind of trap that a student who doesn't have the calculator falls into. They'll list x equals 0 as a vertical asymptote. This next step, so we already know that's not a vertical asymptote because we found it in the other case. And it doesn't have to be at 0. It could be anywhere there's a fake asymptote. It's not real. How do you know for sure something's an asymptote or not if you didn't have the calculator? Well, the only way you can do this is by brute force. You actually have to list all points around and see if it's going up or down. So you choose So the first value I got was x equals 0 as a potential asymptote. So I go to 0 on a number line and choose a number just before 0 and just after 0. Negative 0.01 is before 0 and positive 0.01 is after 0. And I just put them in the x value table. And I do that for every single one of the points. So for example, -5 was a potential vertical asymptote. So I go a little bit before -5, which is -0.0001. You can choose anything you want. Make sure it's really close, because if you choose it too far away, you won't see anything. Another one to the right of it is -4.999 repeating. Here's 5. That's why I chose each one of these regions. I chose them because they were close to the point that I thought was a asymptote. And then you just get the y values. Remember the function was this ugly 6x squared over x to the 4th. You plug in the actual x value and you punch it through. Now on your calculators, you can use your index finger. Hopefully you're using your index finger and not some other finger to type in all the thing, right? But you can. I think there's a way on your calculator where you can just substitute a different value in there. She's nodding her head. Do you know how to do that? All right, you just became everyone's friend because you don't want to keep typing the same formula in there again and again. So you're going to have to find her if you want to find out a way that you don't have to retype it in, because every time you type it in, it's potential to make a mistake. So I'm not going to walk through the calculations for everyone, but I just found the y values at every one of these. What do you notice about these values here and these values here? What's the difference?
Goes up and some goes down.
But these are all big, right? What about this one? Little. This is not an asymptote. It's either got to go to heaven or hell. This is right around 0. This is the ground floor. So this is not a asymptote, and this is how you can tell. It's not large, so 0 is not an asymptote. But this is before -5 goes way up. After -5 goes way down. Before 5 it goes way down, and after 5 it goes way up. That's what this information is telling me. So when you are graphing a line, you only need 2 points. Because this is a curve with some funky things going around, instead of plotting a billion points, which is what your calculator is doing, you're just trying to pick the special points where there's a problem and then isolate around there and figure out what it looks like. That's what you're trying to do. Questions? We okay? So you're recreating the graph as if you don't have a calculator. That's what all these questions are about. Goes way up before, goes way down after, goes way down before, goes way up after. This is not an asymptote. That's all we have from there.
With the way technology is like advancing, will there ever be like a point when we're not going to have a calculator or like,
I don't know. I feel like as an institution, we're always way behind what's needed out in industry, for example. I'll give you a perfect example. We're building something called a professional science master's. So students will go out, get a job, find out that they don't have the right skills to interface, so they'll come back and get a 1.5-year degree. So as we're planning this, we're thinking we need to have good speaking skills, so we'll make sure you have a speaking class. I was talking to Bristol Myers Squibb, and they said, forget speaking skills, have them learn how to do a webinar. You need to have them learn how to Skype with someone far away and communicate over that Skype. You're behind, you're still behind. So I feel like every step of the way we're just, because many of us don't work out in industry, so how would we know? But with the calculators, because we're not out in the field every day, we don't understand, I think, sometimes that technology will be at your fingertips. It is. You think that I'm crunching these numbers by hand? I'm not. I'm putting them on Excel and running them. So, yeah, I hopefully it will change. It should. Because these are technological tools, it behooves us to keep them from you. And we need to teach you how to use them and use them effectively so that you're competitive when you get out of here. It's really important. Okay, so next step is to find horizontal asymptotes. Choose really large negative and positive numbers. and do the same thing. Plug them in and see what happens. I plugged them in, and that's what my calculator gave me. In Gen Chem 1, if you get these kind of numbers, what do you got? It's really close to what? 0, right? That's a number that's close to 0. Gen Chem 1, you're supposed to always represent things in scientific notation anyways, right? You get the right professor, you're supposed to do that. So what that's telling me is as x goes to infinity, the y value is going to 0 from on top. So David, you were asking, should I stay on top? Absolutely. You're giving more information to put together the graph. So what's that telling me? Well, it's telling me the other piece of the graph. I know right here it does this, and now I know it does this, now I know it does this. And because there's only one more thing to check, and is there any root?
Does that say 6e?
Yeah, that's what my Excel gave me. I don't know what your calculators will give you, but it means 6 times 10 to the minus, right? It's in scientific notation. It's such a small number, close to 0, that your calculator won't give it to you. Last step, find the roots. Set the numerator equal to 0. Piece of cake, we get x equals 0. We already knew that from the original graph. So there's a root at x equals 0, and that tells me that the only crossing, I should have actually filled in the rest of this. The only crossing that you're going to have is right here. That means it has to do this, right? Because it can't cross again, so it can't go up over it, and it has to do this. So now I've got the last piece filled in. I can draw the whole graph that you got in 2 seconds on your calculator anyways.
Isn't x equals 0 a whole though? Because you can't.
What?
Would x equals 0 be a whole though?
It is a whole. So that's one thing your calculator won't give you, because it's undefined at 0. You can't plug in 0.
So then technically would it not have any roots? It doesn't technically cross the x-axis?
You could say the limit is actually, this is a really good question. So the limit as x goes to 0 is going to be 0. You say that. So right over here, what you're going to have is it goes up and it goes down. So while it's technically not a root, it is a seriously important point, right? It tells us what the rest of the shape of the graph is going to look like. So I should have actually, in the video, you'll see the mouse travel. You should have actually connected the dots here, and I have the full graph. So how will you be assessed on the exam? This was a baby problem you guys just got.
I'm sorry, could you say how to find the root? I didn't get that thought.
That one? Okay, so for the one you got in class today was a baby problem. It just had one asymptote. There was not much to it there. The one you're going to get on the exam is going to be more like this one. So all the pieces will be assessed. On WebAssign, you're only asked little pieces of the question because they have to ask you that way because they want you to fill something in multiple choice. So there's no other way for them to ask you the question. They just want you to graph it. So for practice, I would take those WebAssign questions and graph it and see if you can come up. It's great. You already have the answers on your calculator. The only warning I would make is that you make sure to put the whole numerator in parentheses and the whole denominator in parentheses, because if you don't, you're going to get bunk data. It's all going to be junk. Okay, any questions on this? I know today's quiz was hard. I could see it with you working on it. But I'm going to tell you that this was a first. I've thrown stuff at you and everybody's been fine. So I have to say it must be the video, not having the videos and being able to look at it and look at still frame notes. So I would say not life goes on, we'll have to figure it out. I'll say if this is such a great teaching tool, everyone needs to do it. It makes it so much easier. Could you imagine if you had it on your programming classes? You could just look back and see how things are done. I don't get half of what